Now we go to 14.2, derivative of log function. Okay. Before we do the derivative of log function, we need to know that ln is actually the inverse function of exponent. Okay. So we can see from the decimals, this is e to the power x. Then now we have the ln x. Then the graph will look like this. Okay, so we have the y equal to x is this one. So in the chapter 1 function, we know that actually the uh we know that the um how to say we know that the function and the inverse function, their graph is reflected in the uh y equal to x axis. Okay, y equal to x. So it's reflected at y equal to x. Okay. So we know that this is exponent e to the power x. This is e to the power x. And then this is ln x. So it is reflected at y equal to x axis. Okay. So just now we say that the domain for the e power x, for the e to the power x, the domain is equal to is that the x in real number can be any number, and the range is that the y greater than 0. Okay, so for the ln x, domain will be the range for ex, so it will be the x greater than 0. Okay, ln we cannot have 0 here. Let's say we see here ln 0, max error. Okay, and then we have the non-negative number, also max error. Okay, ln only can use for positive number. Okay, can be decimal point. Okay, no problem, but not 0. The x must be greater than 0 for the ex, and the range for ln will be any number. Okay, why? Because you can see that this is same with this, and then this is same with this. So we know that the domain for a function is equal to the range for the inverse function, and the range of a function is equal to domain to the inverse function. Okay. Uh, so this is ln, and now we want to find the derivative of log function, that is ln function. So when we differentiate ln x, it will become 1 over x. Okay. When we differentiate a function x, then we'll have the actually what we will have is equal to 1 over the function x multiplied with the f prime x. Then we simplify, will become the f prime x over fx. Okay, we have ln, then we have the 1 over ax plus b multiplied with a. Okay, but if we want to make it short, then we will just write the denominator part will be the fx, and the above here we will write the f prime x. Okay, so for this one, a, we have the y equal to ln 8x, then the dy dx will become the 1 over 8x, and then we differentiate the 8x will be 8, then it will become 1 over x. And for b, we have the y equal to ln 5x minus 7. Then the dy dx will be over 5x minus 7, and it is 5. So this one, we divide dx for 8x is equal to 8. So it's here. For this one, the divide dx for 5x minus 7 is 5. Then it will become like this. Okay, so C, we have this, we have the y equal to ln 2x squared plus 5. Then the dy dx will be 2x squared plus 5. Then we have the 4x. Okay, why? Is because we have the differentiation for the 2x squared plus 5 is equal to 4x. Yeah. Okay. Next, we have this square root x minus 10, ln square root x minus 10. So we have the y equal to ln x minus 10 to the power of half. Okay. Then the dy dx will be over x minus 10 to the half. And then this one, we want to differentiate this one, d by dx for x minus 10 to the power of half. It will become half x minus 10 negative half 1. Okay, so the power we move in front and then minus 1 become negative 1 over 2. And then we differentiate inside, then it is 1. So this is 1 over 2 x minus 10 negative half times 1. Then it will become 1 over 2 times x minus 10. Okay, what happened here is we have the 1 over 2 and then 1 over x minus 10 power half. The whole thing divided by the x minus 10 power half. So we move down here. Okay, then it will become this. Will be the answer. Actually, this question, we have another method to solve it. Okay, that is, we know that the y equal to ln x minus 10 to the power half. So we know that for ln, the power we can move in front. Okay, so the y is this one. So the dy dx will be 1 over 2, 1 over x minus 10. Oh, then this is the answer. Far more easier than the first method. So for work example number 4, we want to differentiate this one. So we have the y equal to 5x power 6 ln 2x. So we have the uv. U is 5x power 6 and the v is ln 2x. Then the u prime is 30x power 5. V prime is 2 over 2x. That is 1 over x. Okay, because we can cancel. So 1 over 2x and then differentiate 2x is 2 lah. Okay. And then since we have the uv, so we have the y equal to uv, then the dy dx is uv prime plus vu prime. So the dy dx for a is we copy the one in front and then we differentiate the one behind, plus we copy the one in front and then we differentiate the one in front behind. Yeah. Then this one, it will become 5x power 5. And then we have the, no. This is, yes, it's 5x power 5. Because the x and x here can be cancelled. So 5x power 5, 1 plus 30 ln 2x. So the x power 5, x power 5, x power 5 we factorize. And then this one is 5 times 6. So we factorize 5. Then, oh, I made a mistake here. So this will be 6 here. Oh, so this will be 6. This, oh, this is 6. So we have the 6 here. Because 5 times 6, we factorize 5, then we still have a 6 remain inside. Okay, next we look at B. B is U over V. So we have the U over V here. So the U is ln x, the V is 3x. Then the U prime is 1 over x, and the V prime is 3. Okay, so we have the differentiate for u over v will be v u prime minus u v prime over v squared. So the dy dx here is we copy the one down there, okay, dy dx, copy the one down, differentiate the one up, minus the one up, differentiate the one down, and the whole thing divide the one down square. Okay, so this one is 3x squared. The x and x here we can cancel. And then the 3 and 3 here we can factorize. So we have the 3, 1 minus ln x over, okay, 3x squared will be the 9, 3x, the square for 3x is 9x squared. Then we can cancel this one, 3, 3, 9. So the final answer will be 1 minus ln x over 3x squared. A curve equation. This one, the work example 5, they did a mistake lah. The equation is actually this one. Okay, so we not just learn the sine x. Okay, so this is the equation lah. Okay, so we have the y equal to ln. We know that in ln we have the ln a over b. It will become ln a minus ln b. So this one will become ln 2x minus 1 power half minus ln x squared plus 1. Okay, so the one up, ln the one up minus the ln the one down. Okay, so this will become half ln 2x minus 1 minus ln x squared plus 1. Okay, after we simplify, then only we find, this one they want us to show this one, so we show lah. Then hence they want us to find the dy dx. Okay, so it's good that the question asks us to show this, then only asks us to find the differentiation lah. If the question straight asks us to find the differentiation, then some of the students they may do the 1 over the whole thing, and then the differentiate in front and something very complicated. Okay, so after we simplify, to find the dy dx is very easy. Okay, so b here, the dy dx will be half 2x minus 1, 2, minus x squared plus 1, 2x. So the 2 and 2 we can cancel out. Okay, so the answer will be 1 over 2x minus 1 minus 2x over x squared plus 1. So I don't make it as a single fraction. Since the question not ask for dy dx as a single fraction, but the question asks for the value of dy dx when x equal to 1, then what we can do is we just have the dy dx when x equal to 1 will be 1 over 2 times 1 minus 1 minus 2 times 1, 1 squared plus 1. Then the answer will be 1 over 1 minus 2 over 2. Then the answer is 0. Okay. So for this one, if we want to check answer using calculator, okay, so what we can do is we have the liber dx, we have a fraction square root 2x minus 1, and then we have the x squared plus 1 when x equal to 1. So the answer is 0. Okay, so the answer that I get is correct. Okay, work example number 6. A curve equation is this. We need to show this one. Okay, so for this one, we need to change base. Okay, so we need to change base for log. So we have the log AB. It will become log CB over log CA. Okay, this is what we learned in log that. So for this one, we have the y equal to this one. Okay, then the y will become the ln 5x minus 2 over ln 2. Okay, we need to know that ln x is actually the log e x lah. Okay, so we have the log e 5x minus 2 over log e 2 lah. That is ln lah. So we change base here. So after we change the base, then this will become 1 over ln 2 multiply with the ln 5x minus 2. Okay, so sure. B, they want us to find the dy dx when x equal to 2. So this is y. Then we want to find the dy dx. So the ln 1 over ln 2 is just a number, constant. They don't have x. So when we do the differentiation, we can ignore it. We can just move out. So the dy dx will be 1 over ln 2. We differentiate this one will be 5x minus 2, 1 over 5x minus 2, multiply with 5. Okay, so the dy dx when x equal to 2. So dy dx when x equal to 2 will be 1 over ln 2 times 5 over 5 times 2 minus 2. Okay, 10 minus 2, 8. So we have 5 over 8 ln 2. Okay, so I try to check answer for this one. Okay, we have the differentiation for log 2 5x minus 2 when x equal to 2 will be this. 不要这个先生，我才没有教完，继续。哇 Okay, then this will be the answer. And we have the 5 over 8 ln 2. Okay, is this. So the answer is correct. Okay.